Perseverance is a car-sized Mars rover that was built to explore Mars' Jezero crater. It was built by the Jet Propulsion Laboratory and was launched on July 30, 2020. On February 18, 2021, confirmation that the rover had successfully landed on Mars was received. Perseverance has a similar design to its predecessor, Curiosity, though it has been slightly updated. It has 7 principal payload instruments, 19 cameras, and 2 microphones on board. They also differ in important mission-specific ways. Whereas Curiosity has identified and continues to study environments where ancient microbes may have lived, Perseverance will look for direct signs of ancient life and prepare geological samples that a future mission may bring back to Earth. The rover also delivered to Mars the mini-helicopter Ingenuity, an experimental aircraft that made the first powered flight on another planet on April 19, 2021. The Perseverance rover has 4 primary science objectives that serve the science goals of the Mars exploration program: in search of habitability, find historical habitats capable of supporting microbial life; looking for biosignatures, seeking evidence of probable former microbial life in those habitable conditions, particularly in specific rock types known to retain evidence throughout time. Caching samples entails gathering core rock and regolith, soil, samples and storing them on the Martian surface. Testing oxygen generation from the Martian atmosphere in preparation for people. NASA announced Perseverance's destination, the Jezero crater, in November 2018. And the site was chosen from among more than 60 potential contenders, implying how exceptional its features must be. The reason for such intense interest is because Jezero is a true gold mine from both a geological and biological standpoint. The crater, which stretches for more than 45 kilometers, is actually home to an ancient delta built 3.5 billion years ago at the confluence of a Martian river and a lake. One merely needs to glance at a satellite image of it to realize this. Even at first glance, rock formations can be traced back to the delta-like mouths of 3 rivers, 2 tributaries and 1 outflow. The delta's sedimentary bed was produced in very distant times when water flowed across the Martian surface, and the river spilled into the crater, forming a lake. The streams coming into a lake bring fine sediment, which is deposited in vast numbers as the estuary opens and the velocity drops, generating stratifications. It is this uniqueness that may have kept any organic stuff intact at depth. If life existed on Mars at the time, some traces may have been kept within the rocky strata, safe from the atmospheric changes that gradually altered the planet into its current state. Perseverance arrived in the Delta region in April 2022, after spending its first year traversing the bottom of the ancient lake and discovering not sedimentary rock but compact igneous rock, most likely formed by the fall of the asteroid that excavated the crater. Perseverance's mission to look for biomarkers on Mars' surface is really divided into numerous programs, each named after a different area of interest. The Crater Floor Campaign, which began shortly after the rover's landing on Mars in February 2021, directed the rover to the crater floor in search of the best rocks to sample. Perseverance flew south from its landing place, then east to the Seta sand dunes, north to the river delta, and finally west. According to NASA, the rover obtained the long-coveted evidence in that turbulent and extremely fascinating location last July. In fact, Perseverance collected some samples from Wildcat Ridge, a rock formation formed when water slowly evaporated and mud and fine sand settled. A few samples were retrieved from Skinner Ridge, a rock outcrop made of fine-grained sandstone comparable to a type of rock found in many places on Earth. The Skinner Ridge cores seem light-colored, and studied with round grains of black stuff when viewed up close in the sampling tubes where Perseverance is keeping the finds. These darker grains were most likely brought from locations hundreds of kilometers away by the ancient river that previously flowed near Jezero. Thus, studying the grains could reveal information about faraway parts of Mars to scientists. The other set of samples is from Wildcat Ridge, a sedimentary rock about a meter broad that is only 20 meters away from Skinner Ridge. These samples are lighter in color, more homogeneous, and finer grained than Skinner Ridge cores. And, according to Earth's geology, the finer the grains of a rock, the more likely it is to hold signs of past life. On Earth, microscopic grains prefer to settle in low-energy areas like the bottom of a pond, where they can retain decomposing organisms or other evidence of life. On July 20th, the rover began analyzing the collected material with a sophisticated scientific tool known as Sherlock, which stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. And, much to everyone's amazement, Wildcat Ridge turned out to be the richest sample of organics ever discovered on Mars. Hey guys, just a second before we go. Make sure to subscribe to our channel, and by pressing the bell, you will assist us in producing ever higher quality items. But why is this so significant? And exactly what is organic matter? Organic molecules are made up of a vast range of chemicals that are mostly composed of carbon, but may also contain hydrogen and oxygen atoms. They may also contain additional elements such as nitrogen, phosphorus, and sulfur. Although they may be produced by chemical processes unrelated to biology, some of these compounds are thought to be true biosignatures, that is, evidence that billions and billions of microorganisms once swarmed in Lake Jezero's waters, eventually ending their lives encased in the bottom sediments. In practice, the most optimistic hypothesis is that the sand, mud, and salts that now make up the Wildcat Ridge rock were deposited in an environment that could potentially have supported life in the distant past, and the discovery of organic matter in a sedimentary rock A-type that on Earth is synonymous with the fossilization of ancient biological forms is obviously very significant. Does this imply that Perseverance has discovered evidence of life on Mars? No, it does not. We can't be certain. Despite the effectiveness of the instruments aboard Perseverance, further judgments about the contents of the Wildcat Ridge sample will have to wait until they return to Earth for a more in-depth examination. Although, for the time being, it is certain that the river delta within Jezero crater has the same type of sedimentary rocks for which Perseverance was designed and delivered to Mars. As a result, the rover has 43 titanium tubes in which it stores the Martian soil and rock it is investigating. So far, a dozen test tubes have been filled and sealed, and all will be placed in a well-marked location on Mars' surface. The initiative intends to collect at least 20 samples to return to Earth in the future, though the researchers hope to fill all 43 tubes. After collecting the samples, the researchers must select where Perseverance will leave them on Martian soil. It is unclear whether the cargo will be deposited in a single location, or whether they would establish at least 2 distinct depots in order to have backup samples in case something goes wrong. The tubes are projected to keep the samples intact for at least 20 years on Mars, which is a reasonable amount of time for the construction of the recovery mission, which still has many unknowns. NASA and the European Space Agency will launch a Mars sample return mission in 2028. Which would send a new rover to Mars to collect samples and put them aboard a tiny rocket, which will then place them in orbit around Mars. At this point, a probe should intercept the container containing the tubes and return it to Earth. Nothing like this has ever been attempted, but having such samples on Earth would allow for much deeper and more precise investigation in search of Martian life. That is the encouraging news. The less good news, or at least the less immediately satisfying, is that scientists will have to wait a long time to determine whether the elements of Martian biology genuinely represent the long ago, or even existing, presence of Martian biology. In fact, samples are not expected to arrive on Earth until at least 2033. This also indicates that the long-awaited first human landing on Mars will not happen before that date. Meanwhile, the scenario of sample return is our best option for determining whether our once watery planetary neighbor was also a live neighbor. The just-announced Perseverance discovery raises the chance, albeit only slightly, that the answer to that question is affirmative. Alright everyone, here is where the video ends. Thanks for watching, and see you again soon.